discuss types of correlation. We have four types of correlation. Those are positive correlation, negative correlation, simple correlation, multiple correlation, linear comma non-linear correlation. These are the different types of correlation. Let us discuss all these one by one along with some example. So what do you mean by correlation? Correlation is nothing but the covariation that exists between two interrelated variables is called correlation. That is, the change, if the changes in one variable produces the corresponding changes in the other variable, we say that the two variables are correlated. So we have two, these are the following types of correlation. Let us see what is positive correlation. So if you take two variables as, let us take x as rainfall and y as yield. Okay, so a limited increase. So if we observe an increasing trend in the rainfall, we see the corresponding increasing trend only in the yield. Means if we observe that the changes in the both the variables are in the same direction. Whenever if the increase produces the corresponding increase, or if the decrease produces the corresponding decrease, that is, the changes in the two variables are in the same direction, we say that the two variables are positively correlated. Unlike that, if we take two variables x comma y, where let us say that first variable as woolen clothes and temperature. Okay, we say that if the temperatures are increases, that is in summer season, we observe that the sales of woolen cloths are going to show a decreasing trend. Okay, in the first one, positive correlation, we are observing that changes are in the same direction. Unlike that, in negative correlation, if the increase in one variable is producing corresponding decrease in the other variable, that is, the changes in the two variables are in opposite direction, we call that the two variables are negatively correlated. So what is simple correlation? Simple correlation means correlation. What do you mean by correlation? Covariation between the two variables, between the variables is called correlation. If we are studying the correlation between exactly two variables, we call that as correlation with simple correlation. So whenever we have the correlation, name itself tells the multiple means whenever you have more than two variables under study, we call the correlation as multiple correlation. So let us take an example here. Let x be the where x, we have x1, x2, x3 as the x4 as four variables, where x1 indicates the yield of a crop and the x2 as rainfall, x3 as fertilizer we are using, temperature. Okay, here generally in the previous example we have considered yield and rainfall. We have only two variables there. We can consider that as an example for simple correlation. Under multiple correlation, here yield of a crop not only depends upon rainfall, it also depends upon other factors like fertilizer, temperature, fertility of the soil and many more, seeds that we use. So whenever we are observing, we are finding the correlation between more than two variables, we call such correlation as multiple correlation. So here this is the example you can consider. Similarly, the next correlations are linear and non-linear. Linear means we have already discussed the scattered diagram. So whenever you plot a data on a bivariate axis, if it shows a perfect straight line, we say that it is a linear correlation. Unlike that, if it shows a curve, if the points plotted shows a curve we call that as a nonlinear or curvilinear correlation. So we have discussed the types of correlation as positive correlation, negative correlation, simple correlation, multiple correlation, linear and non-linear correlation. So we have discussed that there are two measures of correlation. Those are scatter diagram, which we have already discussed. The second method of measuring it is nothing but Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation that we indicate with small r, which is given by covariance of x comma y by standard deviation of x into standard deviation of y. This is the formula for r, which is nothing but the Karl Pearson's coefficient of correlation, where the formulas for covariance of x comma y is 1 by n sigma xi minus x bar into yi minus y bar, and the formula for standard deviation of x is root over 1 by n sigma xi square minus x bar square, and for sigma y it is root over 1 by n sigma yi square minus y bar square. These are the formulas. While doing problem we can discuss in deep. So this is the second measure of correlation for correlation, which is called the Karl Pearson's coefficient of correlation. So generally we have limits on r, which are nothing but r value always lies between -1 to +1. So using that formula, after calculating r, it should always lie between -1 to +1. Whenever we get a value in negative range, we call that the two variables are negatively correlated. Whenever we get values in positive range, we say that the two variables are positively correlated. So whenever r, if we have in between we have 0, whenever r is 0, we say that there is no correlation between them, or the two variables are uncorrelated. So r is given by covariance of x by sigma x sigma y. R value always lies between -1 to +1. Whenever r is equal to -1, we call those variables are negatively correlated. R is equal to +1, positively correlated. R is equal to 0, they are uncorrelated variables. So the second we have is nothing but Spearman rank correlation. Spearman rank correlation coefficient. So this is also another type of correlation only. Up to now, how we have defined correlation? Correlation is nothing but the covariation between the two variables. We are calling that as two variables. So whenever we have two qualitative, we have generally the data is of qualitative data and quantitative data. Qualitative and quantitative data. When do you call the data as qualitative and quantitative? Whenever the data cannot be measured numerically, we call the data as qualitative data. When it can be measured numerically, we call that as quantitative data. So if you take the examples like intelligence, beauty, and honesty, I think all these are nothing but qualitative characteristics like heights, weights, income, and so on, rainfall. All these are nothing but quantitative variables. So the data generally of qualitative or quantitative in nature. The one which we can measure numerically are termed as quantitative. The one which cannot be measured as numerically are called as the qualitative. So Karl Pearson's coefficient is used to measure the correlation between quantitative data only. We cannot use this R for measuring the qualitative data. So whenever we have qualitative data, To measure correlation between them, we use Spearman rank correlation, which is indicated with rho, which is given by 1 minus 6 sigma di square by n into n square minus 1. Here for quantitative data we use R. So correlation, there is no change in the meaning or the uses of correlation, but when depending upon the type of data, in some cases, means whenever it is quantitative we go for R, whenever it is qualitative we go for Spearman rank correlation. Okay, these are about the types of correlation. Okay, so the next concept which we have is nothing but regression. Another measure of descriptive statistics is nothing but regression. So correlation is nothing but it gives the just relationship between the two variables, whereas regression gives the average mathematical relationship between the variables. Means whenever we have two variables r x comma y, if I write r is equal to 0.7, I can conclude that there is a 70% of positive correlation between them, whereas it just gives the amount of relationship between the variables, but regression gives the average mathematical relationship, which indicates that, let us say that you have x as the same example I am considering, x as rainfall and this as yield. Okay, under regression we are going to classify these two variables as one as the dependent variable and other as the independent variable. Okay, so we have no such discrimination or identification in correlation. In correlation is one concept, one statistical tool which gives just an idea of relationship between the variables, whereas using regression we can estimate the value of dependent variable when the value of independent variable is given. If according to regression, among the two variables or more, if it is a multiple regression more than those variables, we are going to identify one variable as independent variable and the other variable as dependent variable. Because of identifying this type of dependent and independent variable, we can make estimation possible. That is, we can estimate the value of one variable when the value of other variable is given. So, when an amount of rainfall is given, you can estimate the value of yield. Similarly, if you go to yield and income and expenditure, there x comma y, income, if you consider income as x and expenditure as y, expenditure is dependent on income, so we call y as dependent variable here, x as independent variable. Generally y, the one which depends on the other variable is called the dependent and the one which makes the changes is called the independent variable. So if there are two variables, we are going to have two equations here. Means if you have two variables, maybe x may be dependent variable. What is the one case? X may be dependent, y may be independent. What is the other case? X may be independent, y may be dependent. Okay, x may be dependent, y may be independent. In the other case, x may be independent and y may be dependent variable. So whenever we have two variables, we will have two lines of regression. One is regression line of y on x, regression line of x on y. Whenever we call y on x, here y is considered as dependent variable and x is considered as independent variable. If I consider regression line of x on y, then x is considered as dependent variable, y is considered as independent variable. Using regression line of y on x, we can estimate, means it will be in this form. Y is a function of x. So this is dependent, left hand side is always dependent variable, right hand side is independent variable. So we can estimate y when x is given. In the second case, x is a function of y. So here x is the dependent variable, y is the independent variable. We can estimate x when y is given. So this is another concept of descriptive statistics which makes the estimation possible. So we can estimate the value of one variable when the value of other variable is given. So similarly we have two regression coefficients also, byx and bxy. Byx is called regression coefficient of y on x. This is called regression coefficient of x on y. As you have y on y here, here y is the dependent variable, this is the independent variable. This is dependent and independent. Its formula is r into sigma y by sigma x, where this is the standard deviation of y by standard deviation of x. This is the correlation coefficient. As you have y on x here, you will get sigma y in the numerator, sigma x in the denominator. bxy means r into, as you have x here, you will get sigma x by sigma y. So using regression, we can estimate the value of one variable when the value of other variable is given. You will have two regression lines. One is x on y, where x is the dependent variable. You have y on x, where y is the dependent variable, and these are the two regression coefficients. Okay, thank you.